Central tendency application problems. Jay bought gifts costing $24, $26, $20, and $18. She has one more gift to buy and wants her average mean cost to be $24. How much should she spend on the last gift? Method 1. Work backward. In order to have a mean of $24 on 5 gifts, the sum of all 5 gifts must be $24 times 5 equals 120. The sum of the first 4 gifts is $88, so the last gift should cost $32, because then we would get 120 total divided by 5, and that would give us an average of $24. Method 2. Write an equation. Let x equal J's cost for the last gift. Alright, so we have the 4 previous gifts, 24, 26, 20, 18, and then this mystery amount for the 5th gift, divided by 5, so we would take the average of all of those costs, and that would be 24. So then you just solve for x. So you have all these added together, gives you 88 plus x divided by 5 equals 24. So we multiply both sides by 5, and we get 88 plus x equals 120. And finally, we subtract 88 from this side, put it over there, we get x equals 32. Your test scores are 87, 86, 89, and 88. You have one more test in the marking period. You want your test average to be a 90. What score must you get on your last test? Alright, so we have 5 scores. The 4 we already have, and the mystery one that's next, this x. Divided by 5, we want the average to be 90. So we add all those up, we get 350 plus x divided by 5 equals 90. We multiply both sides by 5, we get 350 plus x equals 450. So x equals 100. You need 100 on your test to have a 90 average. Consider the data set. The mean is, alright, so to find the mean, we add all of these together and then divide by the number of numbers. So we have 50 plus 60 plus 65 plus 70 plus 80 plus 80 plus 85 divided by 7. So this equals 490 divided by 7, which equals 70. So the average of these numbers is 70. The median is, well, the center number, there's an odd number, there's 7 numbers here, so the center number is 70, therefore the median is 70, and the mode is 80, because 80 is in here twice. What happens to the mean, median, and mode if 60 is added to the data set? Alright, so if we add in 60, so our new set will be 50, 60, 60, 65, 70, 80, 80, and 85. So to find the average, or the mean, we would add all of these up and then add an extra 60. So it would be all of those numbers again, which I won't rewrite, but 490 plus 60, so we'll add another 16 here, and then divide by 8, because now there's 8 numbers, and that would give us 550 divided by 8, which is 68.75. Alright, our median is now the average of the 2 center numbers, because now there's an even number. So the average of 65 and 70 is 67.5. And the mode, well, now there's an extra mode, because there's 2 80s, but there's also 2 60s. So our mode is 60 and 80. Consider the data set. The mean is, well, if you add all of these up and then divide by 6, you get 58. The median is, well, we have 6 numbers here, so the average of the 2 center numbers is 57.5. The mode is 55, because that shows up twice, whereas all the other numbers are only in there once. What would happen if a value x was added to the set? Well, how would the mean change if x was less than the mean? If x is less than 58, that means the mean would go down. If x equals the mean, then if we added in the number 58 into this set, then the average, or the mean, would remain the same. If x was greater than the mean, say we added a 60 or a 70 in here, something larger than 58, then the mean would go up. Let's further consider the data set. 55, 55, 57, 58, 60, 63. The mean is 58, the median is 57.5, and the mode is 55. What would happen if a value x was added to the set? How would the median change if x is less than 57? So here we have an even number of numbers. So if we added in a number less than 57, say we added 54, that would make the median 57, exactly. So the median would be 57. It would decrease slightly. If we add a number that's between 57 and 58, say if we added, for example, 57.5, the new median would be this value, because this would then be the middle value, because this one's not in there anymore. So we would now have 7 values, and this one would be right in the middle. So whatever number this is, the new number would be the median. If x was greater than 58, so say we added 64 in here, get rid of that one, then the median would then be 58, because we would once again have 7 numbers, and 58 would be the new center number. So it would go up to 58. Consider the data set. The mean here is 17.3, the median is 18, and the mode is also 18. What would happen if the value of 20 was added to the data set? So adding a 20 in here, how would the mean change? Well, the mean would go up because 20 is greater than 17.3, therefore the mean would increase. How would the median change? Well, instead of this being the center number here, we instead would have another number over here, so the median would become an average of the 2 center numbers, which just happened to both be 18. So the median will remain at 18. How would the mode change? Well, the mode is 18 because there's 2, but now there's also 2 20s. So the modes would be 18 and 20. Consider the data set. The mean here is 58, the median is 57.5, and the mode is 55. What would happen if a value x was added to the set if x was 55? So if we add another 55 here, how would the mode change? Well, the mode's already 55 because it's in here twice, and these other numbers are only in there once. Adding another 55 won't change the mode. It'll still be 55. If x was another number in the list other than 55, alright, so say we added in another 63, then we would have 2 modes. We would have 55 and 63. So the other number would also be the second mode. So there'd be 2 modes, one of which would be whatever number we added in. If x was a number not in the list, so say we added in 64, then the mode would remain at 55 because this would only be in there one time.